Hello everyone, this is Vijetha, Associate Professor in the Department of ECE from MLR Institute of Technology. Today I would like to talk on some nonlinear circuits related to op-amp in linear and digital integrated circuits. Hello everyone, this is Vijetha, Associate Professor in the Department of ECE from MLR Institute of Technology. Today I would like to talk on some nonlinear circuits related to op-amp in linear and digital integrated circuits. An operational amplifier used in open loop configuration will operate in non-linear manner, and this can be helpful in many applications where we need a switching between positive and negative saturation levels. And the positive feedback to these circuits provides a hysteresis characteristics. Then some nonlinear circuits using op-amp here I want to discuss are comparator and Schmitt trigger. The first one which I want to discuss here is comparator. An op-amp comparator compares the input signal with a known reference voltage is called as a comparator. These are the ideal and practical comparator transfer characteristics. Here if you can observe, in ideal characteristics there is a spontaneous switching between plus Vsat and minus Vsat, where there is some lag to transfer the characteristics from plus Vsat to minus Vsat. This is the difference between the ideal and practical comparator characteristics. And coming to comparators, either you can connect the comparator in a, these are the ideal and practical transfer characteristics of an comparator. Here the comparator can be connected either in a non-inverting comparator or in a inverting comparator modes. First we will talk about the non-inverting comparator. That means the input voltage has to be connected to a positive terminal, then only it is said to be a non-inverting comparator, and the difference voltage, that is known voltage, has to be connected to a negative terminal. A fixed reference voltage V reference is applied to the input and the time varying signal Vi is applied to a positive terminal for a non-inverting comparator. When non-inverting terminal, that is Vi, is less than the V reference, Vi is less than V reference, that is the voltage across the positive terminal is less comparing with the negative terminal. Or we can say that the voltage across the negative terminal is more comparing with the positive terminal. So, your output voltage will be switches to minus Vsat, that is voltage across the negative terminal is more comparing with the voltage across the positive terminal. On the other hand, if Vi, that is voltage across the positive terminal, is more comparing with the negative terminal, that is Vi is greater than V reference, then V0 will be equals to plus Vsat, that is voltage across the positive terminal is more. When non-inverting input Vi is less than V reference, output goes to minus Vsat, and Vi is greater than V reference, output goes to plus Vsat. That is the output switches from minus Vsat to plus Vsat depending upon the amplitude of Vi. Thus, output voltage V0 changes from one saturation level to other depending upon the voltage difference between Vi and V reference. These are the input and output waveforms of a non-inverting comparator when Vi is less than V reference and Vi is greater than V reference. Here in a non-inverting terminal, as Vi is connected to a positive terminal, if Vi is greater than V reference, then output voltage will be plus Vsat. When Vi is less than V reference, as V reference has connected to a negative terminal, this means that V reference is more, then V naught is providing a minus V sat. Let this be the input voltage Vi, which is a continuous input signal. If this Vi is greater than, see, till here Vi is less than V reference. As Vi is less than V reference, till here it is showing it as a minus V sat. Now, when Vi is greater than V reference, it is just reaching above the 1 volt, then it moves to minus V sat to plus V sat. And here, when it comes to a minus V sat, again in this period it will be in a plus V sat. And in this period, it will be in a minus V sat as Vi is less than V reference. In this period, it is Vi is less than V reference. In this period, it is Vi greater than V reference. Now, when your V reference is negative, what happens? When V reference is negative, that means it will be, see here, when V reference is negative, see, plus V sat, see, V in is greater than V reference. Yes, from this point to this point, Vi is greater than V reference. So, the output is providing as a plus V sat till this point. From here, Vi is less than V reference and it immediately goes to minus V sat. It is switching between plus V sat to minus V sat depending upon the input voltage gain and also a reference voltages. Inverting comparator. As the input voltage has to connected with a negative terminal, this is called as a inverting comparator, and reference voltage has been connected to a positive terminal of an op-amp. Here, see, a fixed reference voltage is applied to a positive input and time varying input is applied to a negative input. Here, if Vi is greater than V reference, your output produces as a minus V sat because Vi has been given to a negative terminal. The voltage across the negative terminal is more comparing with the positive terminal. So, V naught is equals to minus V sat. And if Vi is less than V reference, that means V reference is more. So, V naught is equals to plus V sat. It switches between minus V sat to plus V sat or plus V sat to minus V sat depending upon the Vi and V reference. When non-inverting terminal Vi is less than the reference voltage, the output providing a plus V sat. When Vi is greater than V reference, then output voltage producing a minus V sat. Thus, the output voltage changes from one saturation level to other depending upon the voltage difference between Vi and V reference. Now, we will observe the waveforms here. Here, as Vi is connected to a inverting terminal, when Vi is greater than V reference, your V naught will be equals to minus V sat, and when Vi is less than V reference, your V naught will be equals to plus V sat. Now, if, see, this is V in and this is V reference. Vi is greater than, see, till here Vi is less than V reference. So, here output is producing a plus V sat. When Vi is greater than V reference till this edge, it is producing a minus V sat. And again, from this point to this point, Vi is less than V reference. So, it is producing a plus V sat. Now, this happens when V reference is considered as a positive voltage. Now, when we are considering a negative V reference, then see here, from this point to this point, V in is greater than V reference. So, it is producing a minus V sat. Again, from here to here in this way, your V in is less than V reference, minus V reference. It is producing a plus V sat. So, this is how an inverting comparator output will be provided depending upon Vi and V reference. Now, the another nonlinear circuit is a Schmitt trigger. Here, we are using a positive feedback. The comparator circuit designed with a positive feedback to avoid an unwanted triggering is called as a Schmitt trigger, which is also called as a regenerative comparator. The regenerative comparator or inverting Schmitt trigger consisting of an inverting comparator provided with a positive feedback. The input voltage is applied to a inverting terminal and the feedback is connected to a positive terminal of an op-amp. The input voltage Vi triggers the output voltage V0 every time it crosses the voltage levels, and these voltage levels will be given as upper threshold voltage value or lower threshold voltage. Now, let us assume V0 as plus Vsat. So, the voltage across this terminal can be given as opposite voltage, that is V reference, that is R2 divided by R1 plus R2 into Vsat minus V reference. So, if we have a positive Vsat, we will be getting upper threshold voltage value, and that is given as V reference plus R2 by R1 into Vsat minus V reference. And now, let us assume that V0 is equals to minus Vsat. Let us assume that V0 is equals to minus Vsat. Then you can write the lower threshold value as V minus Vsat minus V reference. And the lower threshold value is given as V reference minus R2 by R1 plus R2 into Vsat plus V reference, which is equals to lower threshold value. If you can observe, it forms an hysteresis where hysteresis is given as upper threshold voltage minus the lower threshold voltage. Here, when Vi is just above the reference voltage, it moves to a minus Vsat. It switches from positive Vsat to minus Vsat and providing a upper threshold voltage value. And now, when it is just below the V reference, the minus Vsat moves to a plus Vsat and produces a lower threshold voltage value. And the difference between this upper threshold voltage value and lower threshold voltage value forms a hysteresis, which is H, defined with H. So, if you can subtract this V reference plus R2 by R1 plus R2 into Vsat minus V reference and minus V reference minus R2 by R1 plus R2 into Vsat plus V reference, will be getting it as a 2R2 Vsat R1 plus R2. Just difference between this upper threshold voltage value and this lower threshold value. That is, upper threshold voltage value is V reference plus R2 divided by R1 plus R2 into Vsat minus V reference is upper threshold value. If you can subtract these two, you will be getting a hysteresis curve or hysteresis voltage, which is given as VUT minus VLT is equals to 2R2 Vsat by R1 plus R2. This is about his Smith trigger. In this, we have discussed comparator, that is inverting comparator and non-inverting comparator, and Smith trigger. Inverting comparator, input voltage, that is Vin, has to be given to a negative terminal, and Vin is greater than V reference, your V0 will be equals to minus Vsat. Vin is less than V reference, V0 will be equals to plus Vsat. Whereas in non-inverting comparator, your input voltage connected to a positive terminal, where Vin is greater than V reference, V0 is equals to plus Vsat, and Vin is less than V reference, your V0 will be equals to minus Vsat. Whereas in Smith trigger, input voltage is connected to a negative terminal and resistive feedback is connected to a positive terminal. For an inverting comparator, if you can have a feedback resistive, then it is working as a Smith trigger. For a inverting comparator, if you can keep a resistive feedback network, it works as a Smith trigger, and it forms a hysteresis, which is given as difference between upper threshold voltage value and lower threshold voltage value, and the hysteresis value is given as 2R2 into Vsat divided by R1 plus R2. This is what discussed in this video. Thank you.